see. Yeah, looks like it's working. You guys see slide 2, right? Awesome, I see a thumb up. All right, great. So yeah, a little bit about myself. Harrison had a great intro. I'm Trevor. I'm a data scientist on a geospatial intelligence team at John Deere. I currently kind of lead the area of quantitative similarity. And then aside from that, I work on a lot of agentic workflows, and I do a lot of projects on AI evaluation. Before I was working at John Deere, I was in school for quite a while, and I kind of finished that out by getting a Ph.D. in horticulture from the other UW, from University of Wisconsin-Madison. So there I was doing a lot of kind of multidisciplinary research at the crossroads of agriculture as well as machine learning and remote sensing, which is kind of a subfield of applied data science focused on images and sensors and collecting information about phenomenon from a different distance. So this is me here off to the right of this with my lab at the time that I was graduating. Yeah, when I was first wrapping that up and then entering industry. Um, and maybe before I go any further, I'd kind of like to get to know the group a little bit. I know we're talking a bit, but does anyone here have any experience with like data science or AI machine learning projects? I heard a couple people before things started. Yeah, we got hand from Harrison. Yeah, feel free to just throw up a hand if you want to type something or hop on the mic, feel free, but definitely seeing a bunch of hands all over. Awesome, that's great. So I think that AI ML is like a really great, really interesting field in general, but especially right now, it's really excited to be in. When I was kind of proposed to give this talk, I had the suggested topic of something in, I believe it was AI and data science in your future career. And that kind of that really had me thinking about back when I was in school and about to graduate and transition into industry, and then when I was first getting my first job in industry and what that transition was like and what it was like applying for jobs and interviewing and upskilling and all that. And yeah, I kind of just got this idea to give this talk on basically what applied machine learning projects look like in industry and maybe how that's different from something you've done in school or with side projects, and maybe just a few things that you could learn and take note of to consider going forward as you're transitioning into anything outside of what you worked with, anything like internships or postgraduate roles, anything like that. So to kind of start this off, I just wanted to say that if you're in this call, you've probably learned a lot. You're in school for something related to technology and computing, and that's a difficult field with a lot of breadth, a lot going on. And yeah, if you've gotten here, there's probably a ton of theory that you've learned, and you've probably gotten a lot of good practical exposure. But despite that, I think I would still say that this transition into industry can be super tricky. I remember feeling like I had gotten a great practical education, but still had a ton of trouble making that transition. And in particular, it's tricky because the problems that you work with are often messier and longer and less defined. Furthermore, success is often measured pretty differently in industry, at least that was my experience. And finally, you're probably going to be working with stakeholders that have a lot of differing priorities between each other as well as yourself, and that in general offer a lot less oversight. So yeah, I was thinking that this talk would get a bit of experience, a bit of exposure to what it's like to work on these projects in a real industry setting. So came up with this idea of focusing on bridging the gap there, and I've split it into 3 sections here. So first we'll be talking about application, about how machine learning and data science and AI are all applied in industry, and then we'll spend a good bit of time focusing on execution, looking at what projects in industry really look like as you're executing them, and then finally, just a bit of talk on growth and how you can maybe be prepared as someone entering industry in one way or another to really take things on. So To dive right in, I wanted to start by maybe just defining machine learning. I'm sure everyone here has heard about machine learning and probably plenty of people work on it, but it'd be nice to get all on the same page. So I would just generally say that machine learning is typically defined as a system that can learn and adapt without being explicitly programmed. This is something that is pretty important. Instead of explicit programming in machine learning, the system has exposure to examples, and it's through repeated iterative exposure that the learning happens. This graphic here kind of shows what that typically looks like. An input will typically be given to the system, and then the system will produce an output, which is then kind of graded. We'll get some feedback on the output, and that feedback is used to retune the system. And as I said, this process is done iteratively to facilitate the learning that the system has. And so I'd like to kind of just start out by saying that machine learning really isn't rare, even if it can kind of seem technologically intimidating. It's something that we interact with every day. And I'd maybe take a moment to ask anyone here, feel free to type or speak up. Yeah, to think of ways that maybe you probably interact with machine learning on like a regular daily or weekly basis. If anyone wants to just shout out or type something up, feel free to go for it. Yeah, all right. And if no one's bold, that's totally fine. I'll say from my point of view, recommender systems are a great way that I like to interact with machine learning. I love like, my next song or movie or YouTube video. I love that we have recommender systems out there that have learned exactly what I want to watch next, and they can do a pretty good job of predicting them. And yeah, that's something that I get a ton of utility out of pretty much every day. Yeah, would anyone else like to hop on in? See a couple
I use it for
hands.
everything: predictive text, autocorrect, voice assistance,
Yes. Yeah.
facial recognition
Yeah.
for my phone.
Honestly, I use it for everything. Is a great answer. I think that's totally true.
I think I, I think I mean about web traffic and search engines.
Yeah.
They have been using ML for quite a while. They
Yeah, absolutely. Yeah, that's definitely a way that you regularly interact with machine learning. So I threw some examples up here. I think that you guys hit a bunch of big ones. There's ones that we think about, ones that we maybe don't think about, and everything in between. And I really want to focus on these types of systems on these slide because these are all major products that we see at tech companies or companies using technology. And the real secret on it, even though I'm a data scientist and I want to pretend like I do everything, the reality is that data scientists aren't doing 100% of this work. Um, these systems are super complex and have a ton of work that goes into them from all sorts of different directions. So even if you're not strictly a machine learning, AI, data science person, it's still absolutely a possibility that you'll work on systems like these. Maybe you're interested in pure software engineering, maybe cybersecurity, something like networking. Even if you're working in those roles, it's absolutely possible that you'll be exposed to systems based around the data science project workflow. So I really just wanted to point that out because the content in this talk is pretty broad. It's something that a lot of people will end up having some exposure to. So to get a little more specific on machine learning in industry, I'd like to start out by pointing to this funnel on the right. This is something colleagues and I refer to all the time. It's kind of the data science funnel. And it shows that in industry, data science projects typically start from a broad business use case and then kind of work their way down through data manipulation, machine learning pipelines, model training, all of that into a deployed tool that is there to kind of meet this business use case. And that's something that when you're in school, oftentimes research in academia does a good job of connecting machine learning problems to real life problems, but you maybe aren't leading on business use cases as much as they do in industry. Specifically, when you have predictions that support business solutions, you're thinking about things like increasing revenue, improving safety, personalizing products, things like that. Moreover, in industry, I found that machine learning systems are often part of larger systems. So they're oftentimes integrated into things like pipelines or dashboards or apps or business processes. It's not just a model being delivered on its own, it's a model adding value to a more comprehensive system. And then I'd finally mention that in industry, full life cycle becomes really important. So you end up doing constant iteration from proof of concept to minimum viable product, and then expanding and expanding. And even after deployment, you're iterating on things. And as you take ownership of these full life cycle industry problems, really starts to include maintenance and retraining and even eventually deprecating tools. And these are all things that as I was transitioning into industry, I kind of wish that I had been made aware of ahead of time because you just do them pretty differently. Now, I am definitely the type of person that likes to be grounded in something real when I'm learning. So as I kind of continue into future slides where we talk about how machine learning problems are executed, I thought that it'd be nice and it'd be kind of fun to tie them back to a theoretical toy data science problem. So as we talk about what happens in data science projects, I'll reference what they would look like for a price prediction project. So something where maybe our business use case is to maximize revenue by predicting the optimal price of some product. And we'll walk through all of the steps on how that becomes a deployed tool, which would look like something like a live pricing system that's used on the shelf or on a digital storefront or something like that. Awesome. So with that, we'll kind of get into the meat of the talk here and share what I'm kind of referring to as the anatomy of a data science machine learning project. And, you know, it's always hard to break something into a strictly modular linear workflow, but this is more or less how I typically see data science projects go. And it's all things that, kind of as I said earlier, I think having this frame of mind as you're maybe applying to internships or postgraduate positions is pretty helpful because you can start to think about how things are going to work when you're in industry. Maybe you can speak more informed when you're talking to interviewers about what projects would look like, and you can really probe your skill set for strengths and weaknesses that you can start to work on. So with that quick overview, the anatomy of a data science project that typically begins with problem framing. Then from there, we go to data collection and data preparation, and then sort of slide into exploratory data analysis. Following that, we'll have some steps on modeling and model application. Then typically we'll have some kind of final evaluation, and then that will move on into a final deployment, and then finally maintenance. So yeah, we'll just go through these one at a time and talk about what it looks like in an industry setting. So starting with is problem framing. This is something pretty critical, and it usually consists of uncovering business objectives and then framing those objectives as a machine learning or data science task. And with that, you'll start to consider assumptions behind the data science task, and then importantly, define success metrics. And this is something really important. Maybe plenty of people in this call will have a bit of a software background, and there's a term called test-driven development that software engineers use all the time. With data projects, kind of the analog to that is evaluation-driven development. And yeah, it's really important to come up with your success metrics at the early stages of a project. So to refer back to the price prediction project, what this would look like would be connecting with some stakeholders to talk about business objectives surrounding pricing. Maybe you determine that if we could find the optimal price, then we would start to increase revenue and make sure that everything's as efficient as possible. From there, you could frame it as a machine learning data science task and maybe start to think, okay, we could model the prices that lead to the highest revenue based on incoming data, you know, things like product data, metadata around the product, sales data, geographic data, things like that. From there, you could consider assumptions about maybe the underlying data, maybe assumptions about who's using the model, how it's being used, etc. And then finally, you would define your success metrics. And I'll talk a bit more about this later on, but focusing metrics on things with the model as well as with the overall system itself and your methods of evaluating your business objectives. So from there, we can kind of move on to step 2, which is data collection and preparation. And here we start to do things like consider data sources that are available. So thinking very practically here, if you're working maybe across an enterprise, you need to see what data you can actually get your hands on. And of that data, what may be effective for finding signal for this problem. In addition, you'll want to clean and pre-process data at this point. And this is honestly a real science that you can spend a lot of time working on. And I really encourage people interested in data science to do so, to look into it. But in general, what this would look like is maybe for the pricing example, grabbing that data that I mentioned, sale history, product metadata, things like that. And then cleaning it by looking for maybe prices that are outliers, maybe looking for null values, missing data points, or invalid data points that won't work with the model. And then finally, pre-processing. So there's a ton of steps to do that, but maybe just getting your model, your features ready to go into the model and connect with it and work there. So moving on into the next portion, this is exploratory data analysis. And this is kind of where, as I was mentioning, it's not strictly linear. You'll do a bit of this as you're in step 2 as well, but this is really where it finds its home. And here you're assessing data quality and you're uncovering patterns and trends in the data that will eventually inform model design and model assumptions. So this could look like making some histograms of the features that we selected for the product pricing system, and then maybe uncovering some relationship between the features. So maybe we find that the past few months of sale data is critically important for evaluating the optimal price point, but maybe something like geographic data or last year's sale data isn't so important, so we don't need to bring it into the model. From there, we could go into the section 4, which I focus on modeling and model application. Here's where we start to assess our modeling techniques. We do some model selection. If we're training a model, we train it. If we're just utilizing a pre-trained model, that's where we start to run it and set it up. And then finally, this is where we think about maybe where a model fits specifically into the system design of the application itself. Now, to refer back to our pricing prediction model here, this could look like evaluating overall what type of model we want. Maybe if we're predicting prices, we want a model that is strong at predicting continuous numeric values. This is something that, for terminology, we would call a regression model. Beyond that, you can do model selection. So maybe you would audition a few models and start to look on some training sets at maybe which ones perform the best. Then from there, you can do some full training and then start to see maybe from a system design point, if you were to make an API that hits your model, how could that play into the entire business problem? How could we maybe have a live pricing system connected to our price prediction model? Something like that. So next step is evaluation, and you're kind of evaluating things the whole time, but this is where it's really important. We start to take the applied model that we have, and we're interested in looking at all sorts of metrics. I kind of group them as model metrics, system metrics, and then business evaluation metrics. And it's important to get all of these. And I remember definitely when I was working more in an academic or a self-teaching point of view, I wasn't as thorough here. I kind of did model metrics and stopped there. So of course, we want to see how the model performs, get metrics that evaluate what's going on with the prediction itself, but we also want to try to quantify and evaluate what's happening with the system. Maybe how fast is the system, looking at latency, maybe you look at the cost of running the system, cost of inference, cost of maintenance. Things like that are just as important as model metrics itself when it comes to putting something into production in industry. And then beyond that, there's business evaluation. Looking at the metrics that you're interested in from a business standpoint, things like revenue, but also things, like customer satisfaction. Are customers happy when they get optimized pricing? Are there any complications when that happens? Yeah, and this is where things can start with synthetic data and then really continue on evaluating through the next two stages, deployment and maintenance, as things get more employed in the real world. So beyond that, we've got the deployment section. So this is a pretty big topic. Surely three bullet points won't cover everything that's going on here, but in general, deploying data science projects is totally different in an industry environment than any others that I had experienced before. So here you're typically connecting to a delivery platform. So maybe that planning that you had done of how an API that hits your model would connect into the entire system starts to be executed here, and you start to set up ML ops, machine learning operations, look at quality and testing and things like that, and then maybe finally you make a business rollout plan. So when I was in school, when we were happy with the model, maybe we would write a paper on it and maybe put it to GitHub, but that would be about it. It wasn't this gradual rollout that you get in industry. Yeah, whereas here with business, you would kind of develop it over time, start with synthetic data, move on to maybe co-op testing, then start having data scientists do A/B testing on a small portion of the user base perhaps, and then expand it out from that. There's usually a very detailed business rollout plan with this, which was totally new to me when I was in this situation. So then finally, we have this maintenance stage. So this is when the model's out and you just need to keep track of things. And there's actually a lot of work to be done here. And again, this is something I got totally no exposure to before I was in industry. So monitoring is something critically important here, both monitoring the performance of the model itself, but also importantly, monitoring the changes in the distribution of the underlying data that the model uses. So unlike when you take a static benchmarking data set when you're making toy models, models in industry on real world data oftentimes can suffer over time because the distribution of the data that it uses starts to change, maybe as consumer habits change or anything like that, with real world data kind of altering over time. Moreover, you also have to monitor feedback loops, which are where your model being introduced actually disrupts the distribution of the data used to make the project. So that could look like something for a pricing prediction model coming out and influencing sales data that the model was originally trained on, changing how it interacts with the users that are using it. All of this kind of goes into this like continuous retraining. This retraining can be done on a schedule, or it can be triggered by the output of monitoring and feedback loop checking and anything like that. So retraining actually becomes an important part of keeping models out in industry and maintaining them. And then I'd finally just mention this life cycle management section. I had mentioned full life cycle before, but yeah, this is something pretty critically important that will want to pay attention to as you're deploying something in industry. So everything from what you did in the development and deployment stages, and then everything after, from maintenance to eventually maybe replacing it with a new model or approach, or just fully sunsetting the project. This full life cycle thing is something that is a little hard to prepare for when you haven't done it before. So that was quite a lot of talking on my end here, and I want to bring this back to this idea of bridging the gap. The reason that I felt motivated to share that was because at the time I didn't really know what execution of machine learning and data science projects was like in industry. And as you're filling out your resume, starting to think of how to frame the work you've done, as you're trying to interview for jobs, and then as you're in your maybe first 90 days trying to get used to the jobs, this is all information that is really important for your future career. It's important to know, and maybe moreover, it's important to maybe, as I said earlier, be able to probe your strengths and weaknesses and identify, hey, here's something that I need to spend a little more time on and get a little more comfortable with. So kind of to come back to something I said earlier, the transition into industry can absolutely be tricky. So if there are a few takeaways that I would want you to leave this talk with, it's maybe to keep these end-to-end workflows in mind, to think of projects more from a full impact point of view. Think about the business results and motivations of projects that you do. And then finally here, I have a note of interacting with your community to get exposure. Aside from just thinking about starting new projects, I also wanted to maybe do some stuff that I've learned since spending time in industry and being on hiring committees to talk about how to stand out in interviews. So just had a few points here that I wanted to hit while we have a little extra time. I've learned that it's really important to build and maintain a portfolio. Having an up-to-date portfolio is really important, and it's something that usually when a job unexpectedly comes up for you, it's hard to do in a high quality way last minute. It's really nice to just maintain something strong, keep a lot of references, things like that. I might also mention participating in your community, something I said on the last time, but the last slide, but that's something that's critically important standing out in interviews here. We love to see people that are reaching out to their community, maybe doing projects, going to workshops, things like that. Specializing, I think, is really important. Staying flexible is a caveat there. You don't want to pigeonhole yourself, but typically teams that I'm on will hire someone that ideally does what they already do. They have some sort of specialty, specialty there. And it's not that they have to be an absolute expert. They just need to show that they're experienced with it beyond the average candidate. So I would really advocate for finding something that's interesting to yourself and then, looking into it, digging into how and why it works, doing some side projects there. That kind of goes into this next point of trying to deploy something. We have a hard qualification. We always want to see people that have proof of work, I think is the term we use. So if you have a GitHub with something that you've deployed, that's absolutely something something that people love to see. And then finally, I just have a note that contributing to open source is another great way to really stand out amongst the crowd in interviews. Okay, that's all I have prepared. I definitely want to say thank you for your time here, but if anyone has any questions or I don't know, comments, anything like that, we definitely have time and I'm happy to keep talking. So yeah, thank you very much. Let me know if you have any thoughts. Cool, I see a hand right off the bat. Oh, go for it though, Harrison.
No, Veronica.
Okay, sure.
Oh, thank you. For my GitHub profile, do you, so obviously we have a lot of assignments that we turn in and we use GitHub to turn them in. But do you recommend we take them like any steps farther to like once we've learned and done the project, then like continue and like enhance it to make it even better so that it's for the lasting duration and presentation of a portfolio worthy project?
Yeah, that's a good question. If you're doing something for school already, you're kind of asking if it makes sense to work on it extra afterward to try to beef it up. And I would say if you have the capacity, then that's absolutely a good way to stand out. At that point, a lot of the hard work's done. It's already up and you have the ball rolling. And if you can think of ways to make it seem like a more mature project, really the higher maturity a project can have, the better it ends up looking. And I would say one really mature project is probably better than a few things that you kind of did a bit more quickly. So if you already have a leg up, you've already started a big project, I would say absolutely take it as far as you can. It's my thoughts there. Yeah, thank you so much. Cool. Anyone else have any thoughts or questions? Yeah, Harrison, want to hop on?
Have you ever heard of AI agents, everyone? I believe that is like one of the latest topic out there.
Yeah.
So very recently, I just discovered that ChatGPT introduces its own AI agent function into the chat itself, and I tried it out. Very surprising. Gave it like a task to build a discounted cash flow, and then it went on to work for like 13 minutes, and then gave me like a spreadsheet with its own model where it trained a model itself, and then ran the model, and gave me the result. Automatically went online looking for references and stuff. So it's crazy. It's crazy what an
Yeah,
AI agent can do nowadays. And I believe an AI agent is, I mean, it's new, but not relatively that new. I mean, this technology has been around for like uh, more than a year, and people are gradually picking it up. But then suddenly, it is available on ChatGPT right now. So I'm like, wow, technology is progressing so rapidly. In this
absolutely.
landscape, in this landscape where things are changing day by day, the thing that you learned yesterday will probably be obsoleted by next week. How can we keep up with, you know, all the trends out there?
Yeah, yeah, that's absolutely an important consideration. Keeping up with trends in, I think in the tech field in general, but especially in the data science, machine learning, AI field is super tough. I would say it's a bit of a balance, but try to focus on learning like the overarching themes of what's happening, more so than any specific framework. And I've noticed when I read like textbooks or even blog posts by industry professionals, the best ones are typically written in that way. It's less of a guide for a certain framework and more philosophically, here's how you approach problems. When you think about a lot of the kind of famous computer science textbooks, things like, what is it, designing data intensive applications. If that's not it's something close. Things like that, they've been around a long time because they focus on the fundamental ways to approach these types of problems. And yeah, I think that keeping that focus is pretty important. When I learn AI engineering, which is kind of a topic I've been focusing on the last year or so, um, it's less about sticking to any one specific framework and treating it like a software problem and understanding how everything connects. So I would say overall that should be a focus, but there is a bit of balance there where it makes sense to, you want to do something, so pick something that's accessible and usable and use it to get results. Yeah, finding a bit of a balance there is important. And I would say across all of the teams I've been on at my current job and previous ones, using tools like that and picking them up rapidly is totally encouraged. Of course, used responsibly, but all of my managers have encouraged us to use things like coding agents or Gen AI to help us make high quality products more rapidly. And I feel like the strongest scientists and engineers on our teams are the ones that are already set up with whatever the most useful hot tools are. I think our best scientists are using agents to code their problems in their projects right now. So yeah, that's my 2 cents on that. I think keep it foundational, but keep up to date with things. Cool. Thank you, Harrison. Jeff, I see you got a hand up.
Thanks, Trevor.
Yeah, Trevor, thanks. So I had a question. So your PhD was in horticulture, which is awesome. In terms of machine learning and AI, did you have to seek out those courses, or was that part of your curriculum? Just wondering what your path was.
Yeah. Thanks for asking. I definitely had a bit of a funny path. My dissertation was multidisciplinary enough that I got exposure to a decent bit of machine learning, but I think the majority of what I use was self-taught. And I was in a nice position where I had like strong machine learning graduate students to bounce ideas off of and ask questions to. But I think it's so helpful to have domain knowledge when you enter a field as a data scientist, but the sacrifice there is that you're not as booked up on the machine learning end of things. So yeah, the last few years, especially in the last year of grad school, I was really, yeah, reading a lot on my own, doing side projects, things like that. And even if I hadn't been so pushed into a domain, I think even students learning technology should still be encouraged to seek out self-learning for the specialty that they're interested in. But yeah, I would say it was definitely a bit of a rickety path for me. There was definitely going out on my own to learn a lot of things. Yeah, thanks for the question. Really appreciate it. What do we think? Anyone else have anything they want to pop in and say? Awesome. Looks like I'm hearing some crickets. I feel like that means everyone said their piece. I again really appreciate everyone's time here. Is super fun giving the talk, and I'm glad that there is some interaction. Glad there are some questions. You guys were awesome.
All right, last chance, everyone. We won't be
Can we
keeping
reach
this
you
up
on
for long.
LinkedIn?
Oh, you know,
yeah,
that's
sure.
a great idea. That's absolutely something I planned to do and didn't. I think there's a chat. Maybe I'll just throw my account in here. Let's see. Yeah, totally was going to throw the QR code up and everything. Yeah, I'm not sure if there's a chat or if there is, I have access to it, but maybe just look up Trevor Crosby on LinkedIn and
Can I type in chat?
I can't, no. Here, I don't know, maybe I can throw that one's on me, my bad.
I'll put it. Okay.
Awesome.
Thanks some money.
Yeah, it's just LinkedIn/Trevor Crosby. So not rocket science. And maybe I would say absolutely leverage LinkedIn if you're looking for jobs. I've gotten all of my jobs off of LinkedIn in the past. It's one of those things. In my personal life, I'm not a social media guy, but absolutely has made a big impact on my career. Even like to just use it every now and then to keep up with people that you meet and to try to connect with recruiters, things like that. For better or worse, LinkedIn is a super powerful tool that I would encourage you all to spend some time on.
That's right, everyone. Up your LinkedIn game. Well,
Up
that
your
includes me
LinkedIn
as well.
game. Yep. I need it too. Awesome. Well, thanks for your time, everyone.
Well, thank you for sharing with us today, Trevor. Hope the best for you in the upcoming endeavors.
All right. Absolutely. Take care, everyone. Have a great rest of your day. Enjoy the weekend.
Thanks for coming today, everyone. Take care.
Thank you.
Thank you. Thank you.
Thank you.
Thank you.